If you need some help with standard form, putting numbers in standard form, converting to ordinary form, and also with those standard form calculations, then stay along, stay with me in this video where I go through everything you need. Converting between standard form and ordinary numbers is where we're going to begin. A number is in standard form if it's written as a number between 1 and 10. It's got to be greater than or equal to 1 but less than 10 times 10 to the power of something. For example, this number here, 3 multiplied by 10 to the power 4, is a number in standard form. It is an integer or a number, it doesn't have to be an integer, it's a number that's greater than or equal to 1 and less than 10, and it's being multiplied by 10 to a power. Now, why do we need to put numbers in this form? I mean, we could also write that number as 30,000, but why is it easier to write it as 3 times 10 to the power 4? It's all to do with very large numbers and very small numbers. So scientists are often dealing with both. For example, if you're trying to measure the size of a bacterium, it's going to be an extremely small number, but the distance between planets, for example, is a very large number. And when we're using calculations and when we're talking about these numbers, it really helps to have it in a form that's number 1, quick to write, and number 2, quick to talk about, okay? So that's why we use it for very large and very small numbers. And as we progress in this lesson as well, you'll see how it makes calculations easier. Okay, so let's cover that then. So first of all, an ordinary number is a number written like 300, 210, etc. And I'm going to first show you how to convert between those ordinary numbers in standard form. The first step is to find a number within this that's going to be between 1 and 10. So where can we put our decimal point to make this number between 1 and 10? So 300 currently has the decimal point there. If we move it back a place, it's going to the number 30, and back one more place would take it to the number 3. And it's that number 3 that is the value between 1 and 10. So we start as 3. Now, 3 times 100 is the same as 300, isn't it? But 100, we remember we have to write it as 10 to the power. 100 is 10 squared. So the answer is 3 times 10 to the power 2. 3 times 10 to the power 2, because we'd have to multiply 3 by 100 to get it back to its original number. The next one, 210, where can I put my decimal point to make that number between 1 and 10? So if I put the decimal point between the 1 and the 0, that's going to be the number 21. Greater than 10, that's no good. Let's go back a place value. Now it's 2.1. That number is between 1 and 10. So we're starting with the number 2.1. Now, what has 2.1 got to be multiplied by to get back to 210? Well, multiplied by 10 will give you 21. Multiplied by 100, or 10 squared, will give you 210. So it's 2.1 multiplied by 10 squared. 5,215, where am I going to put my decimal point to make the number greater than or equal to 1, but less than 10? Well, 5,215 is too big. Let's try putting the decimal point back one place. 521.5, too big. 52.15, it's still too big, so 5.215 is where it's going to be. So we have the number 5.215. What have I got to multiply that by? How many powers of 10 have I got to multiply that by to get back to the original number? So if I multiply it by 10, I'll end up with 52.15, times it by 100, I've got 521.5, and it's going to have to be multiplied by 1,000. So times 10 squared times 10 cubed to get back to the original. So 5.215 times 10 cubed is the number in standard form. Okay, when we've got numbers less than 1 though, we need to think about this a little bit differently. So we're aware that multiplying by 10 makes a number bigger. What makes a number smaller is dividing by 10. So if I had the number 300, we know that is 3 multiplied by 10 squared. But what about if I had the number 0.3? Well, I've got to start with the number between 1 and 10. So that's going to be the number 3. My decimal point is going to have moved now to this position after the 3. Now, how do I get back to 0.3? I've got to divide it by 10, but I can't write divided by 10. I need to write times by 10 to a power of something. Okay, so a little bit of extra learning here is this. If I just do a separate box up here. Now, dividing by 10 is the same as multiplying by a tenth. If you times a number by a tenth, you're basically dividing it by 10, right? So that's the first step. Dividing by 10 is the same as multiplying by a tenth. But how do we write a tenth as 10 to the power of something? You may or may not have covered negative powers yet, but timesing by a tenth is the same as multiplying by 10 to the negative 1. If I'm dividing by 10, we're actually multiplying by 10 to the negative 1. A way of looking at this is if you want the number smaller, then we're multiplying it by a negative power. So 0.05, where have I got to put my decimal point to make the number between 1 and 10? It's going to be here after this 5. So the first number is 5. We're starting with the number 5, multiplied by 10. Now, it's got to go back 2 places, 2 places. So we're dividing it by 10 squared, which is the same as timesing it by 10 to the negative 2. So if the number's getting smaller, it's a negative power. The next one, where am I going to put my decimal point? Well, it's got to be between the 3 and the 6. 3.67 is going to be my number. Now, how many places does the decimal point have to go back? 1, 2, 3. So we're dividing it by 10 cubed, which is the same as timesing it by 10 to the negative 3. Okay, the next one then, the decimal point. Where's the decimal point going to go to make the number between 1 and 10? So greater than or equal to 1, but less than 10. It's going to be here between that 5 and the 9. Okay, so we're starting with the number 5.91, and we're multiplying it by 10 to the power. Well, it's got to go divided by 10, 10 squared, 10 cubed, 10 to the power 4 because it's 4 places. So we write it as 10 to the negative 4. So when those numbers are getting smaller, we're using that negative power because it's the same as dividing. And when the numbers are getting bigger, when we need to make a larger number, we're multiplying it by 10 to a positive power. Let's have a go at converting then from standard form back to those ordinary numbers. Remembering a positive power makes the number bigger, a negative power makes that number smaller. So 3.2 multiplied by 10 to the power 4. What I think it's a great idea to do is just write out the number 3.2. Now 3.2 is the same however many zeros you put after it. We are making the number bigger by 4 place values of 10, okay? So we're multiplying it by 10 4 times, 10 to the power 1, 10 to the squared, 10 cubed, 10 to the power 4. Our decimal point is now going to be there. So we can write out the number. It's going to be equal to 32000. 0.0 doesn't need to be added, so it's 32,000. And I recommend doing the same for each one. So we're starting with the number 5.21. You can write as many zeros as you need to after, and that decimal point is moving 3 times 1. The number is getting bigger. It's being multiplied by 1,000. So my decimal point is now here. So it is 5,210, and keep going. 4 times 10 squared. Now the number 4 is just 4.000. The decimal point is currently directly after the 4. These numbers need to get 100, it's 100 times bigger. We're multiplying it by 100, so 10 squared moves it to there, and it's going to be 400. Okay, now we've got those negative powers. 3 multiplied by 10 to the negative 2. Remember, that's making the number smaller. It's the same as dividing by 100 in this case. So start with your number 3. Now the decimal point is currently straight after the 3. We're making the number smaller. We're dividing, so so we need to put zeros before that number because it's going to be getting smaller. Now 2 place values smaller, so it's going to be 1, 2. My decimal point is now there. So my number, look, is this 0.03. Let's try that again. 8.2 multiplied by 10 to the negative 4. The number's getting smaller. We want our zeros before the number. 8.2. The number's going to be getting smaller. We're dividing it by 10 4 times. 1, 2, 3, 4. Your decimal point is now there. giving you the number 0. Be careful here, decimal points there, 0.0008. And then there's the 2. Okay, so when your numbers are getting bigger, when you're multiplying by a positive power of 10, put those zeros after the number. When your number's getting smaller, put them before for those conversions. Always feel free to stop and go back over these videos if you need something to be gone over it again. Right, we're now moving on to calculations with standard form, and often scientists use standard form because the calculations, and mathematicians, because the calculations become easier. So when we're multiplying and dividing, for example, we can use index laws here to help us. As an example, if I had to do 2 multiplied by 10 to the power 4, multiplied by 3 times 10 to the negative 2, just as an example, this is how we would do it. We split these up. We're doing 2 multiplied by 3 to start with, and 2 multiplied by 3 is 6. And then separately, you're going to be doing 10 to the power 4 multiplied by 10 to the power of negative 2. Okay, when we're multiplying indices, if I had 10 to the A multiplied by 10 to the B, we add those powers. That would be 10 to the power A plus B. So we add these numbers together. We're doing 4 add negative 2. Well, 4 add negative 2, add the negative, make a negative, make a subtract. So we're doing 4 subtract 2, which is equal to 2. We end up with 6 multiplied by 10. We're doing 4 subtract 2 is 2. So 6 multiplied by 10 to the power 2. So do the numbers first and then do the powers separately after. And it's the same for division. So if we had 8 multiplied by 10 to the power 4 divided by 2 times 10 squared. Once again, start by doing the 8 divided by 2. 8 divided by 2 is 4. Then 10 to the power 4 divided by 10 squared. If we're dividing powers, we subtract them. And let's just do a little box on that. So if we had 10 to the A divided by 10 to the B, that is equal to 10 to the power A subtract B. We subtract those powers from each other. So we have 4 subtract 2, which is also 2. 4 take away 2 is 2. So 4 multiplied by 10 squared would be your final answer. So that's a quick way of doing those calculations in standard form. When we get onto the exam style questions, you'll see some with a calculator, and I'll show you how to do it with a calculator as well. Okay, when it comes to addition and subtraction, I highly recommend you converting them into ordinary numbers prior to doing that calculation. So if we had, for example, let's just do 8 multiplied by 10 to the power 4 added to 2 multiplied by 10 squared. I would completely convert those into ordinary form numbers first, before adding them together, and then converting them back into standard form if it wanted it in standard form. So 8.02 multiplied by 10 to the power 4 in this case. So multiplying and dividing, there's no need to convert, but when it comes to addition and subtraction, I certainly would. Right, let's get on then to the exam style questions that are associated with these, and these are the types that you will get. So exam style questions on standard form. Circle the number written in standard form. For that, you need to remember the first number is greater than or equal to 1 and less than 10. So that one is not in standard form, look, because 0.6 is less than 1. This one is in standard form, so I think that's the answer, but let's check the others. 60, nope, that's too big. And we're not going to have a power of 0.4 there. It's going to be an integer value. So 6 multiplied by 10 to the negative 4 is the answer for that one. And then we get our simple 1-mark questions where we're just asked to convert either between ordinary numbers to standard form or the other way around, standard form to ordinary numbers. So 824,000, where's our decimal point going to go to make that number greater than or equal to 1, but less than 10? It's going to go between the 8 and the 2. So we have 8.24. Well, with our decimal point in its new position, how many times do we have to multiply it by 10? So that would be multiplied by 10 would be 82.4 times 100. So 10 times 10 squared times 10 cubed times 10 to the power 4 times by 10 to the power 5 to get it back into its original position. So 8.24 multiplied by 10 to the power 5. Okay, and then going from standard form to ordinary, remember the negatives and making that number smaller. So we're starting with the number 7.9. And we know we're effectively dividing by 10 each time. So let's put some zeros in front of the number, and we're dividing by 10 twice. So it's going to go to, that would be divide by 10 once, divide by 10 twice. Our new number is 0.079. 0.6 divided by 100, so we're starting with the number 0.6. We're dividing it by 100, so I'm going to put some zeros in front. That would be divide by 10. That would be divide by 100. So we know that our answer is 0.006, but it wants it in standard form. So in standard form, we know it's going to be 6 to make that number greater than or equal to 1, but less than 10, multiplied by 10 to the power, divide by 10 squared, divide by 10 cubed. So to the -3, because that 6 needs to get smaller by 10 to the power 3, dividing by 10 to the power 3. Work out this and give your answer in standard form. So to do the calculation, we're doing 40 multiplied by 30 to start with. 4 3s are 12. Zeros are there, so 2 zeros. 1,200 times 10 to the power 5. Right, I am tempted now to convert that into a ordinary number. So that would be 1,200 with 5 extra zeros on it. And then if we consider that in standard form, it's going to be 1.2 multiplied by 10 to the power 1, 2, 3, 4, 5, 6, 7, 8. There we go. Okay, shall we have a look at a couple more questions? Just going to write that out again. So we have 3 multiplied by 10 cubed to 5 multiplied by 10 to the -1. And we want the right-hand side of the ratio to be 1. That means we need to divide this side by 5 times 10 to the -1. Okay, so we need to do the same to the right-hand side, divide it by 5 times 10 to the -1. And we can use our calculators for this question. So we're doing 3 times 10 cubed and we're dividing it by 5 times 10 to the -1. Now, just to be sure on this, I would put it into brackets as the 2 separate parts. Okay, so that gives us 6,000. There we go. Right, write these numbers in descending order. Descending means you're starting at the biggest and you're going smaller. Starting at the biggest, going smaller. So I would convert them all into ordinary form to start with. So 9.46 times 10 cubed, so times 10 would be 94.6, times 10 squared, 946. So we're going to have to put another 0 on there, and it's going to be 9,460. Now this one, 9.46 times 3 to the power 10. This was a calculator paper, 9.46 multiplied by 3 to the power 10 gives us 558,603. And I'm going to put some dots after that to show that it continues. So in terms of descending order, we're starting with the largest, which was this one here. So you would write 9.46 multiplied by 3 to the power 10. The next smallest was 9,463. And then it's 9,460, making sure you write out the original 9.46 multiplied by 10 cubed. Right, one more then, another calculator set of questions. 8.68, so once again, input it into your calculator using those brackets. So we have 8.68 multiplied by 10 to the power 9, closing those brackets, divided by 3.2 multiplied by 10 to the power 4, closing those brackets, and it wants your answer in standard form. So I would start by writing out the full answer. So 268,750, but it wants it in standard form. So our decimal point is going to go between the 2 and the 6, giving us 2.6875. Zeros are not needed on the end there, will not make a difference to the number. Times by 10 squared, 10 cubed, 10 to the power 4, and 10 to the power 5. Okay, 2 marks there. 1 mark for getting your first number correct between the 1 and the 10, and the second for the correct power on your 10. Second one is another calculator question. Now, if it's given as a fraction, just put it in the same format into your calculator. So 6.08 multiplied by 10 to the power 14 over 4.1 multiplied by 10 to the power 9 Okay, write out the full number to start with. So 148,292.6829. But once again, it wants it in standard form. So our decimal point is going to have to go here, giving us 1.48292.6829, and we're multiplying that by 10. Right, how many places does it have to move to get back to the between the 2 and the 6? So that would be times 10 to the power 1 to the power 2, 3, 4, 5 to get back into that same position. So 1.482926.829 times 10 to the power 1, 2, 3, 4, 5. Okay, there we go. Right, hopefully that's helped with your knowledge on standard form. That's a lot of the type of things that you need to be able to do for foundation. Subscribe if this has been useful, and I'll see you for some more videos.